The personal protective equipment, PPE, worn by actors in this video was selected based on a risk assessment of the chemicals used in the experiment and conditions simulated in the activity. In scenes where the presenter did not wear PPE while in the lab, all chemicals were removed to eliminate chemical hazards.
The ability to recognize hazards is important for designing and carrying out safe lab experiments. In this video, you'll learn to recognize chemical hazards using written sources of information. Recognizing hazards is part of a larger process for evaluating safe lab procedures called RAMP. RAMP stands for Recognize Hazards, Assess Risks, Minimize Risks, and Prepare for Emergencies. Each experiment or process presents its own set of hazards. All hazards need to be recognized so their risk can be assessed and minimized. This video will focus on hazards from chemicals, but there are other hazards associated with lab work such as high pressure, low and high temperatures, and electrical hazards. In the United States, chemical manufacturers are required to supply a safety data sheet, or SDS, with information about their chemicals. The SDS follows the United Nations globally harmonized system of classification and labeling of chemicals, usually referred to as the GHS. The SDS is an important document and crucial for your safety in the lab. It's the first place you should go to determine the hazards of chemicals you'll be working with. All SDSs have the same 16-section format, but we'll only look at the 7 sections related to recognizing hazards. Now let's take a closer look at the SDS for some chemicals commonly used in the lab. Section 1 identifies the chemical. It's crucial you have the SDS for the right one. Chemicals sometimes have several names, and these will be listed on the SDS. Also make sure the concentration is the same. If you're working with glacial acetic acid, which contains 99% acetic acid, you don't want an SDS for vinegar, which only contains 4%. Finally, every chemical has a unique Chemical Abstract Service registry number. This identifier and the name on the container must match the number on the SDS. Section 2 lists hazards for chemicals in several ways. The most direct way is a list of hazard statements. There are 78 official hazard statements in the GHS. Most chemicals only have a few of these. Every SDS will also have pictograms, symbols representing different categories and hazards. Each pictogram represents a specific type of hazard. There are 9 pictograms. Most chemicals have only 1 or 2 pictograms. The hazards of ethyl ether, for example, can be immediately recognized in any language with the 3 pictograms: flammability, irritant, and health hazard. Section 2 also provides a signal word, either warning or danger. This gives us a rough estimate of the relative degree of hazard. Finally, Section 2 also lists precautionary statements. These provide advice for using the chemical. You can see that ethyl ether has a long list of these statements. Section 4 provides first aid information for each way a chemical might enter the body. These typically include the eyes, nose, mouth, and skin. You should consider these routes of entry when thinking about how a chemical could harm you. Section 8 includes exposure control terms such as TWA and PEL, which stand for time-weighted average and permissible exposure limit. Generally, low numbers here mean serious inhalation hazards. For comparison, carbon monoxide has a TWA of 25 parts per million, while ethanol has a TWA of 1,000 parts per million. This means you need to be more careful about exposure to carbon monoxide than ethanol. Section 9 summarizes physical and chemical properties. The boiling point and flash point are used to determine flammability. For example, the flash point for ethyl ether is quite low at negative 45 degrees Celsius. This indicates that vapor easily forms and could ignite at room temperature. Section 10 tells us about the stability and reactivity of the chemical. For example, nitric acid is very reactive and has a long list of known incompatible chemicals. Incompatibles are listed in this section. Pay special attention to this section when disposing of waste. Many lab incidents are caused by accidentally combining incompatible chemicals in the same waste bottle. The SDS for ethyl ether says it shouldn't be mixed with oxidizing agents or strong acids such as nitric acid. Section 11 provides info about the toxicity of a chemical, the dose that can harm you. This is often expressed as lethal dose, LD50, or lethal concentration, LC50. The number 50 tells us how much of a chemical it took to kill 50% of a test population of lab animals. The toxicity of a chemical is divided into acute or short-term effects and chronic or long-term effects. We worry mostly about short-term effects in the lab. With ether, a single exposure may cause drowsiness or dizziness. In fact, it was once used as an anesthetic for surgery. Overall, SDSs are useful, but they aren't always the best source of safety information. This is partly because SDSs are written for a variety of audiences, so some information is not very relevant in the lab. In particular, pay attention to the terms no data available, N/A, and not established. If you encounter the phrase no data available, it should be viewed with some caution. It could mean data hasn't been reported for the property of the chemical. After all, there are many tens of thousands of chemicals in use, but only a small percentage have been tested for toxicity. Or it could be the person who wrote the SDS simply didn't include information that is readily available. Above all else, you shouldn't interpret no data to mean this chemical is safe. It just means we don't know or we didn't look. For common chemicals, there shouldn't be many of these no data entries. Not applicable is used for properties which don't apply to the chemical in its specified form. For example, you wouldn't expect to see a melting point or freezing point for a gas. If you see N/A, it can mean either not applicable or not available. Here are a few other concerns about SDSs. For one, they are not legally required to be accurate. Studies have shown that some SDSs have errors and omissions. Second, SDSs for the same chemical can vary between manufacturers. And finally, sometimes they present accurate, but not very helpful statements like dispose of waste according to local regulations. If you can't find what you need in an SDS, there are other sources of useful info about chemical hazards. First, there's the PubChem Laboratory Chemical Safety Summary, or LCSS. These are similar to the SDS, but use different section numbers. An advantage of the LCSS is it shows combined information from many sources. Another resource is the National Fire Protection Association Fire Hazard Diamond. Numbers from 0 to 4 indicate hazards for firefighters. 0 means non-hazardous and 4 means very hazardous. Colors define the type of hazard. Red indicates flammability, blue a health hazard, yellow an instability hazard, and white is for special instructions such as OX for oxidizers present. Keep in mind that information resources can only state hazards, not assess risks. You will always have to assess the risk of using certain lab chemicals. Depending on how much of a chemical is used and how it is used, even a very hazardous chemical can present little risk. Remember RAMP, the 4-step process we mentioned at the beginning of this video? Recognizing chemical hazards is an important part of this process. Over time, you'll learn how to read an SDS with a critical eye so you can use chemicals safely, but with reasonable precautions. To learn more about the other steps in RAMP, be sure to check out the other 5 videos in this series. You can find them by clicking here, checking out the links in the description, or visiting acs.org/safetyvideos.
Take 2.
Fact, it was once used and as an anesthetic. I think I'm saying it right, but I don't know. Like PubChem Laboratory.
Right, come here.